Hello everyone, welcome to our HIMMAT.net. I'm Calvin, and today we're going to talk about partial fraction. So in your previous study, if we had two fractions and when we got common denominators and evaluate the fraction, we would get a single fraction. For instance, 2 over x minus 1 plus 3 over x minus 2 equals 5x minus 7 over x squared minus 3x plus 2. But for partial fraction, we're going to do the opposite way. You're taking a fraction that already been combined, and then you have to decomposing it in the separate parts. So we discover here the purpose of partial fraction decomposition is to find the parts of a single fraction. We can break this fraction into these two fractions. If we add these fractions, we will get these single fractions. Okay? Now the question is, why would we want to do this method? Partial fraction decomposition can help us to solve the more complicated fractions, and it is very useful in integral calculus. The thing that you have to make sure of is the degree of the numerators has to be strictly smaller than the degree of the denominator. See, the numerator is a linear polynomials and the denominator is a quadratic polynomial. Okay, now let me show you how to do it. First, find the factors of the denominator. The factors of x squared minus 3x plus 2 are x minus 1 and x minus 2. And then we have to break the polynomial function to several polynomials, when the denominator will be x minus 1 and x minus 2. Next, you have to write the polynomial expression on the numerator with one less degree from the denominator. For example, this one is linear equation, and then you have to write a constant on the numerator. This one also a linear equation, so you have to write a constant on the numerator. And then we have to evaluate these polynomials. And we got a times x minus 2 plus b times x minus 1. And then we write down the denominator, x squared minus 3x plus 2. And then we have to simplify these polynomials, and then we got a plus b times x minus 2a minus b over x squared minus 3x plus 2. Now we have to compare this polynomial with the original polynomial. So we can conclude that 5 is equal to a plus b. 5 equals a plus b. And minus 7 is equal to minus 2a minus b. And from these two linear equations, we got a equals 2 and b equals 3. Okay? Now we have to substitute the number to this polynomial. So the answer is 2 over x minus 1 plus 3 over x minus 2. There you go. Now let's try another example. Now we have 3x squared plus x plus 4 over x cubed plus x. First, we have to find the factors of the denominator. And we got x and x squared plus 1. Sometimes the factors of the denominator is an unfactorable polynomial, and it is fine. Now we have to break this polynomial function to several polynomials. Next, we have to write down the polynomial expression on the numerator with one less degree from denominator. For this polynomial, we have to write a constant on the numerator. And in this case, the denominator is a quadratic polynomial. So we have to write a linear polynomial expression on the numerator. For the example, like this: bx plus c. And then we have to evaluate this polynomial. And we got a plus b squared plus cx plus a over x cubed plus x. And then we can conclude that 3 is equal to a plus b, one is equal to c, and 4 is equal to a. So we got b equals -1. And then we have to substitute this number to this polynomial. So we got 4 over x plus minus x plus 1 over x squared plus 1. Let's try another example.
Sometimes the factor in the denominator occurs more than 1. For instance, 8x squared plus 8x plus 2 over 4x squared plus 1 raised by 2. As we can see, the factor for x squared plus 1 occurs 2 times in the denominator. So we have to separate the fractions by forming fractions containing increasing power from 1 up. For instance, 4x squared plus 1 plus squared plus 1 squared. Now we have to write down the expression on the numerator. In this case, we have a quadratic polynomial, so we have to write down a linear expression on the numerator. So we have ax plus b. This one is also quadratic polynomial with raised by 2, so we have to write down a linear expression too. So we have cx plus d. And now we have to evaluate the polynomials. And we got for a x cubed plus 4b x squared plus a plus c x plus b plus b over 4 x squared plus 1 squared. And now we can conclude that 0 is equal to, for a, 0 equal to 4a, 8 is equal to 4b. Eight is equal to a plus c. Two is equal to b plus d. And we got a equals 0, b equals 2, c equals 8, and d equals 0. And now we have to substitute this value to these polynomials. And we got 2 over 4x squared plus 1 plus 8x over 4x squared plus 1 squared. There you go. Okay, I hope this video will help you with your homework and your study. Thank you for watching.